Hello, this is Keith Cheatham. No, I'm not the guy from the law firm. I retired from Dewey, Cheatham, and Howe many, many years ago. No, I've got this old gas-powered welder that is pretty much junk as it sits, but I'm going to try to turn it into something maybe better than it ever was. We will see.
What we have here is a Lincoln SA200 short hood welder. I acquired this thing in November of 2024. This thing was built in 1952 by Lincoln Electric. My mission is to make this look good, run good, and well good. That is, simply if it is economically feasible to do so. This is just one of the long line of SA200s built by Lincoln, but the short hood is a distinct version of the SA200 Lincoln produced only in the late 40s through the mid 50s. The short hood is known to be an exceptionally good welder, and particularly when it comes to heavyweight welding. Here you see the doors and the exciter cover all in pretty bad shape. I built this work stand custom sized to the welder. This is going to help a whole lot. Okay, what I first want to do is look at the condition of this thing as it is before tearing into anything. At the time I acquired this machine, about all I knew, other than what I could see, was that the engine would rotate by way of a hand crank. So the following will be a review of the conditions as it is. This auxiliary DC outlet is obviously junk. It will be replaced. This current selector, you might call gear shift, is completely froze up. It will not budge. This rheostat knob turns and the rheostat turns, but I put an ohm meter on it and it's just terrible condition. I'm gonna replace it. It's not worth trying to clean the contacts or anything to me. I'll just put a new one on it. These welding lead lugs look terrible, but I'll remove them both front and back completely, check the insulators out, and see if it'll clean up, and then I'll get some new wing nuts to put on it. These gauges are obviously trash. I'll just replace them. I'm going to see if I can find a new faceplate just like this one that has a place where I can put the code number and serial number on it also. I'm going to be customizing this control panel and adding all of the other controls to this panel, so everything will be right here. Lincoln used a Continental F162 flathead 4-cylinder 4-cycle gas engine on this machine. Continental called it an L head. It looks like rusty brown radiator fluid there at the radiator cap, but it's not. It's all you can see there is a shield that was built between the radiator core and the cap, and as you'll see, I found it quite interesting what I actually found about the radiator fluid during the teardown. The radiator as a whole looks pretty good considering all the time it spent out in the elements, about 73 years, and don't see any physical coil damage. What is there of the fuel to from the tank to the carb is a total mess. I'll simply be replacing it all. The generator looks like junk. Looks like it's probably only being used as a tensioner pulley for the belt. Here's another original component with this old canister type oil filter. We will see. I'm just suspicious of the magneto creating a spark as it sets. This machine, as I received it, didn't have any sort of air filter. This governor is the only throttle control while welding. I hope it works. This is another original equipment Marvel Schiebler carburetor. This is a combination intake and exhaust manifold. No holes or cracks that I can tell. Looks okay. Geez, just amazing. Multiple things going on here, at least a couple of things. This controls the low RPM of the machine in an effort to control stabilize the voltage going to the auxiliary plug when it is in use. Hoping it works. We will see. This is the negative ground battery cable. It's a piece of junk. The end of it won't even latch onto the battery. This choke cable is bent and all, and I'm gonna put it around to the front, so I'm gonna get a longer choke cable. This is the kill switch cable, and going to the magneto, and it cuts off the power. It's going up here to an old type switch that all of this stuff is broke, so that's gonna have to be replaced. This here is your start button, which I figured it probably wasn't good. I put my ohm meter on the back side of it, and it would never close, so it don't work. Now here's the positive cable. It's fair, but the end of it's terrible. So, and it's got a couple of bad places in it. I'm gonna replace it. I clamped on a battery and jumpered the solenoid with a screwdriver. And it kicked in, turned the engine over a couple of 3-4 turns. I stopped because haven't done the oil and stuff yet, but. Okay, now for the dipstick check. All I can say is, oh my goodness. Oh my, and then also, there's at least 2 times the fluid level in the drain pan. I mean, it's probably 1.5 inches or 1.25 inches over the full mark the fluid level is. Well, we'll see. I drained the oil pan without capturing it in video, and I was so disgusted, especially after seeing what came out. This is exactly what it looked like. Crystal clear water for about 10 to 12 seconds. And then it turned to pure oil. Here's the aftermath. You see the water splatters. This is a 16-quart container, and it was probably at least 3/4 full. There was about 12 quarts in this container, most of it water. And from what I saw, the water and the oil was completely separate. I think this water entered the engine through the exhaust stack for sitting in a pasture for probably 20 years, never being used. I'm going to tear the engine down, see what it looks like, and go from there. Removed the hood. I had to saw a couple of the bolts, the hook bolts. The nuts just would not come off of them. I removed the exhaust stack and found this. Yeah, I'd say rainwater's been coming through the exhaust stack. Next, I started removing the upper radiator hose, and then, oops, there's radiator fluid everywhere. So I stopped, pushed the hose back on, and started draining the radiator. I had first opened this drain cock and nothing would come out. So after finding radiator fluid, I looked at it closer and found that it was plugged. I got the plug in the external opening of the drain cock cleaned out, and I got the radiator coolant drained and captured, and it looks pretty clean. I got the upper radiator hose removed and began to dismantle the oil filter canister. A view of the top of the engine head. Oops, when I cut the two bands strapping the tank to the two saddles, it became apparent that this angle iron frame piece broke loose from a previous weld. It looked like it had been tried to be repaired with a weld, or some other time. But we'll fix all this when we're going back together with it. Okay, about to get this engine ready to take the head off. I got the generator unmounted, the oil filter taken off, and I'm taking the water pump off now. Um, this other side, here's the intake and exhaust manifolds all lined up together. They're just kind of made together, and they come out at separate. It's for each cylinder. Carburetor is off and sitting over here. I'm going to go through that, put it in a vat and get it cleaned up and go through it. There's the tank fittings. There's the oil filter stuff. That's the intake and exhaust manifold. Don't think it's going to have to be replaced. I've seen some that got holes in them and stuff, but there's the generator bracket, and there's the exhaust stack and some of the radiator connections, and then here's the fuel tank. It's all in real good shape. There's not a thing wrong. I'm just gonna flush it out, clean it out, and I don't see any water damage. It looks pretty dang good to me. The cylinder walls are in absolutely perfect condition. No signs of water damage whatsoever. Okay, we're going to take a close look at what we discovered when I took the head off of this Lincoln Welder F162 Continental engine. See there, this is the front of the head. That's not supposed to be there. There's 3 little pings in that cast iron head machined like BBs. Something got in that head. Something metal, obviously, something pretty hard, and got slammed up against the top with the piston. So let's look at the piston. And this is where we discovered something not all that good. There's dings there in the piston. There's some dings in it. And then that's the center of the piston. All of them have a little indentation in the center. But then there's a hole right here, and unfortunately, goes all the way through. So this piston, this cylinder, has not been adding any energy to the system at all. So to take a job that we were going to try to stay above the bottom just turned out that nope. Got to take the engine out, oil pan off, and do pretty much a complete job on the engine. I will be taking a much closer look at this number 1 cylinder head and piston damage later in the teardown. I'm going to review this engine's camshaft, valves, and piston action before going any farther. The graphics point out cylinders 1 through 4 as shown. Then this illustrates the firing order. This diagram shows the strokes for each cylinder of this F162 as it relates to the rotation of the crankshaft. The following video will illustrate the strokes on cylinder number 3. I'm going to use the valves and pistons on cylinder 3 to illustrate the 4 strokes of a 4-cycle combustible engine. This engine is setting here now with cylinder 3 at the start of the intake stroke. The cylinder will be traveling down with the valve open, pulling air and fuel into the cylinder. As the piston reaches the bottom of the stroke, the valves will be closed, and they will stay closed as the piston starts traveling back up. This is the compression stroke. After piston reaches the top, the spark plug will fire and combustion happens, and this is what's called the power stroke. When the piston reaches the bottom of the power stroke and starts back up, the exhaust valve will open, and this will start what's called the exhaust stroke. With the piston at the top of the exhaust stroke completes the 4 strokes of a 4-cycle engine, and the process starts over again. Now back to the welder. This is the current switch, and this is the main stator brush hood, the main stator brushes. Wasp nests throughout this thing. There's probably 20 or 30 of them. The top of the engine block after removing all the head studs.
Getting it ready to pull the engine and armatures. It'll probably be, we got a few things we got to do the rest of the day, but I'll probably work on it some more today, but getting it there. There's the radiator and there's the framework. This valve lifter cover. There's the governor and the mag and distributor. Spark plug wires. It was wired wrong. Somebody had stuck the cables in the wrong spot. Here's the side. All the valves and everything are working properly, but we're going to completely tear down this engine, so I'm going to be taking it out, separating it, turning it over, and put new seals in it, and possibly new bearings. And I know I'm going to put new pistons and rings, because this one piston's got a hole knocked in it. Don't know what happened there, but might find something out in the bottom of it. I don't know. It sure all works. I mean, you rotate it around, everything works perfectly. All the valves move. It's real quiet, smooth. Nothing. Okay, I'm going to do this by taking this apart from this end. There's some wiring. There's some of the wiring that has got to be replaced, and maybe it's just the wiring. I have checked both of the armature coils, and they're not grounded, so I don't know. Maybe that's a good thing. Anyway, I'm going to take it off piece by piece on this end.
till I get back this way and prop that end of it up and take the deal loose and take the engine out and put it on a engine rack where I can rotate it around. Cleaned it up real good and paint it and stuff. Gonna need a 1 5/8 impact socket and impact wrench to get that off. There's the exciter end of it, and I've taken the armature off. The brushes, I've taken them off, but I just latched them back on there to keep everything in place for right now. The armature is over here, and it looks pretty good in my opinion. I mean, I didn't see any place where it looks like it's burned. I have checked from ground to these comms over here and never got a ground on it anywhere, so I think it's okay. There is some you get your resistance in the coils and stuff, but anyway, my mating marks were pretty much useless. It didn't even separate here. There is 3 wires running from the stator to the exciter coils and brushes, and they are in terrible condition. I'll be going back to the best part of those wires and replacing them. I used my own color code with some 88 colored tape I had to identify the wires before I cut them in two. Here's a schematic I made myself for above the stator and behind the control panel. A lot could be said here, but we'll go into that during the rebuild. The engine, the main stator housing, and the exciter housing are all bolted together to be one unit. Then that unit is attached to the framework in 3 points, as shown in this video. Each of the 3 connections is made with heavy rubber grommets, both top, middle, and bottom. This provides vibration dampening, but also the unit is literally insulated from the frame. I completely removed all 4 of the main armature brush holder brackets, and also the 2 exciter armature brushes. I then removed the 4 big bolts attaching the exciter frame to the stator housing. What you're looking at here is what's going to be the juggernaut in this entire teardown of this unit, but I will succeed. As you can see, there's about 1/4 of an inch of the exciter frame bearing housing sticking out past the bearing, which add about 73 years of exposure to the elements, and you've got a booger bear.
I couldn't find a puller with a long enough, extension on it to help on the exciter, trying to pull the exciter off the shaft. So I just made these these longer arms on it there, and this will catch on the back of it, and I can use the threads on it then to help put some pressure on getting it out of there.
Here's the customized gear puller. I removed the exciter brushes, coils, and wiring out of the exciter frame. Just trying to get the bearing to break loose from the housing. Finally, some movement. I'm just going to apply more heat. I didn't capture it on video, but it finally came loose. Hallelujah. It was at this stage in the teardown that I realized I desperately needed some casters on the platform so that it would move around. The armature shaft and main stator armature, flywheel, etc. can now be pulled back through the main stator. With one of the picking eyes fully screwed back into the engine block and the hoist, I began lifting the engine unit up out of the frame. I removed 6 bolts from the engine back plate, screwing into the stator housing. I had to wiggle it and pry on it to get it to start separating. Separating the engine from the framework was quite a chore for one man. 2 people would have been fairly easy. But I had to lift it and then move the platform back, lift it a little, move the platform back, and so forth and so on until I got it out of there. Hooray! No damage. What a mess. Although this wouldn't have kept it from running or welding, but I will clean it all up. Got the engine stand on standby. I rigged up a 2-inch wide strap winch that I had, rigged it up to the building, put the strap around the armature, lifted it up or held the weight of it up while I took the 8 bolts loose from the flywheel, and then I had to turn the armature about 15 degrees or so counterclockwise to get it to unlatch. Just an amazing latch up design. We'll talk about it more on the install. Flywheel removed. Engine backplate removed. Ready for engine stand. Got the engine mounted in the stand. Armature, flywheel, and engine backplate all removed. Got the oil pan removed. I had to go get some longer bolts and standoff nuts to attach the engine to the engine stand, and holding it away from the stand enough that the crankshaft would turn. There was a oil sludge in the bottom of the pan, but there wasn't a water oil emulsion anywhere. Point is, I don't think the engine had ever ran with the water that was in the oil pan. With some silicone gloves on, I fished around in the bottom of the pan in the oil sludge and found a few solid objects. I can't be positive, but I'm kind of thinking the edge of that combustion chamber that chipped off happened first, and then that chip made its way over toward the center of the piston eventually, and caused the dings and the hole knocked in the piston. You can tell there was combustion in the chamber after the chipped off piece came off, either from casting defect or possibly millwork damage, or both. Oil pan removed. Oil pump removed. Here's a look at the crankcase with the oil pump removed. It very, very clean looking. At this date and time, I received my first order of parts. This was the bulk of it. I did have to order a few more items. For this old boy and this machine, this is excellent condition. Here's the number one piston rod and bearings. Except for a hole in it, it looks in exceptional condition. The rings even look new. The front end is where all the oil had been leaking over the years. Just one of the many dirt piles from this thing. I broke one of the brushes. New head bolts. I found this old poly barrel out in the back and cut it in half and got it mounted on here and using it as a catch-all. Works great. I flushed and cleaned this engine block out every which way I could. Got it really, really clean. I went through a lot more cleaning aids than what's shown here, just believe me. This, along with a lot of degreaser, scraping, and brushing, and uh, it was a lot of work, but got it done. I used an oil-based Rust-Oleum rust primer, not seen here, but here's what the rust primer looked like. And here's what the Rust-Oleum gloss gray finish looked like. Both the primer and the paint are oil-based and will need probably 24 hours between each coat. I'm very happy with this paint. It seems it produced a very resilient, hard, easily cleanable surface. While the paint was drying, I worked on the magneto. This right here was the way it was. I changed the points and condenser and cap and distributor cap. I didn't get it on video, but I rigged up a spark plug wire, a spark plug, and a ground wire from the magneto base to the spark plug base. Spun the magneto a few turns and it was sparking real good. I used assembly lube on the cam lobes and the bearings. I torqued the crankshaft back into place. There is straightforward timing gear marks on the camshaft gear and the crankshaft gear. all torque down. See the next clip for torque values. At this stage, use the crankshaft to set the number 4 piston at the top dead center of the power stroke. Now to cleaning up the engine governor. I'm not going to dare tear into this thing. First, there's this very heavy, very strong spring that holds the throttle in the full open position. There's like 3 steel balls on something like a pendulum that swing out with the centrifugal force by the RPMs of the engine. This centrifugal force is converted into a linear force that pulls against the spring, slowing the throttle down. Thus, during welding, when the engine is dragged down, the RPMs go down, and the spring speeds the engine up, and then the RPMs centrifugal force takes over and slows the engine back down. It's just another amazing thing about this Lincoln welder. Now to cleaning up this Marvel Schiebler carburetor. Here is the partially dismantled carburetor. The carburetor body part halves set along with the other parts in the chem dip for 2 days. This choke butterfly valve shaft is still stuck. It will not budge. Well, I goofed up here. I grabbed the lever arm on the shaft with some vice grips, slowly turned it, thought it was moving, and twisted it a little more, and it just twisted the end of the shaft off. Here's the carb ID tag. Here's the new choke shaft and butterfly valve. I got the carburetor all cleaned up and put back together with new gaskets and new choke shaft, ready to install. This photo jumps over the installation of the governor and the magneto, and These are very important timed pieces that have to be timed with the engine for it to run. So I will try to explain. Again, the engine crank must be set with the number 4 piston at the top dead center of the ignition power stroke. Just leave the engine crank at this position throughout the build. You should see timing marks on the back side of the cam gear as shown. The timing of the magneto is actually done by way of the gear on the governor. As you install the governor in its slot, match up the timing marks on the gear with the timing marks on the cam gear. Spin the magneto to where the rotor is ready to fire on the number 4 cylinder. With the magneto set to fire on the number 4 cylinder, the bar key on the back of the magneto should somewhat line up with the slot in the back of the gear on the governor. With the magneto meshed with the governor and in its spot, you will notice on the top bolt location that there is a little slot that allows the magneto, that whole assembly, to be moved slightly in and out. This is for fine tuning the magneto for the firing. Just a FYI, I'm using all new gaskets everywhere in this engine build. But I am also using a gasket maker RTV silicone on both sides of the gaskets on every connection. With this being the bad place for oil leaking, I went ahead and used the RTV on both sides of the gasket and anchored it down right in the dead middle of the slot. That's exactly where it was when I took it apart. I just figured if I had to adjust it, I could get it apart. It might be a chore, but I could do it. I used a right angle grinder and smoothed down the dimpled spots and the chipped spot. Removing the stator. I like the black frame, but not the black control panel dashboard. Several days went by flushing out the fuel tank. I like this dark gray on the control panel, much better. I took apart the current selector switch, cleaned all the parts, and wire brushed all the contact surfaces. This old original current selector pinned knob is going to work much better. I'll be just painting it, cleaning it up, and painting it, using it.
It's got the current speed switch fixed and working. It's original, but refurbished and all that. You take the shift in the front and it actually operates pretty smoothly and nice. Put new springs on it there to keep the tension on it, and got two stops there. Those stops are important. You have to have them, or you know, if you turn that thing too far, it would slide off that bus bar there and then clamp together, and it wouldn't go back without getting in here with a screwdriver to open it up. So works real nice. New rheostat installed, and it's working nice and smooth. Things are coming together. Got some new wing nuts on the old-fashioned like studs.
Just a lot of caked on dirt, oil, and crud was removed from the stator housing. Got the stator housing primed, and here it's painted. The nameplate is masked off. And now for the small gauge aged and damaged wire replacement. I'm using a high-end automotive grade 12 gauge tinned copper wire on this small wire replacement. I'm also using a mechanical fastening method with a brass sleeve and 4 Allen lugs to fasten the conductors together. I'm then applying a heat shrink over the entire splice. I then added a wiring loom harness tape for added protection. All the wiring and heavy cables look good now, ready to go. Here I'm loading the stator back into the frame. After cleaning and sanding and priming the hood, a pretty good sized dent started standing out. Got the fuel tank primed and the hood primed. Engine head installed. Got the engine back on the hoist and picking eye. Okay, mount the flywheel with the timing marks on the back of it visible in the sight hole. Got the engine flywheel back plate mounted, and then the flywheel mounted and all bolted down. Man, that thing is heavy, 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 heavy. Engine, the timing marks line up. It even lined up where, where Lincoln made it. I mean, those marks in there was what I put in there before. So that's the way it was. I didn't pay any attention to that when I was loading it back on here, but they did it right too. So anyway, moving on. Now to get this puppy installed. I'm not going to replace that tail bearing. I'm going to rerun it. It's smooth as it can be, tight as it can be, and honestly, I'd trust it more than I would buying a new one and putting on there. And at this point, just an FYI, this welder is not for sale, and it never will be for sale. So there are four you might call latching studs on the armature mounting assembly. There are four retaining studs on the flywheel that match up with the studs on the armature mount. the stator cooling fan blades are attached with these same bolts. So I should have put it on the armature in front of that strap, but I didn't. I'm carefully cleaning the armature and the comms with a flat, pretty fine grit sandpaper block. You can see the kerosene heater flame flickering on the oil pan. Pretty shiny paint. Now to joining the engine and the stator back together. It, it of course, it would help tremendously to have two people, but I got it. You get the idea. Wow, nice. I love it. Starter in place and ready to go. I have these two wires in the wrong place. More on that later. I began installing the new battery cables and new wiring to the starter button and kill switch, etc. I thoroughly cleaned the tail bearing seat. all snugged up and bolted in. It was a quite easy install. In the meantime, started painting the doors. Finished wiring the starter push button, the magneto kill switch, and the switch to the light for the gauges. At this stage, I wanted to rotate the engine with the starter, so I bumped it, and it sounded like it kicked in, and then it didn't do nothing. It stopped, and the button is dead. So I'm taking the starter to the workbench and take a look at it. After opening up the solenoid, I finally realized there's a wire popped. With the starter in a vise, I hot wired the starter, bypassing the solenoid, and the starter runs. So it's time for a new solenoid. I used a high strength wiring loom tape to harness all the cables. Got the fuel tank ready to strap in. Got the fuel tank strapped in. I got the water pump installed and the intake and exhaust manifold mounted. I doubt the generator's going to generate, but the bearings and bushings are perfect condition, so I'm going to use it as a belt tensioner for now. I added 4 quarts of SAE 10W30 motor oil. With the filter not installed yet, it was only 4 quarts at this time.
Getting this puppy ready to fire off.
The welding components and wiring and stuff are not done yet.
Hadn't put the stack cap on it yet. I haven't bundled these wires down here. I'm gonna wait until I know everything's go on it. Got the linkage to the carburetor hooked up. This is the governor, and it moves positively, left and right. It's on high right now, and it reduces that if it needs to. But this is a double action shaft thing here, and for that big bar goes back here to your vacuum idler, and this goes the other direction when that, and then you can pull this all the way up here, and that pin right there, then, and put it in that hole and lock it on, minimum low idle. Choke is working. The choke cable pulls the choke.
Okay, after doing some double back flips and hoorays, I went in the house and asked my better half to come out and watch. And so what's following is the actual second startup and run.
For loud.
I had turned the fuel valve off.
I don't know what happened.
I should have had the idler vacuum line valve shut off. Watch what it does.
It's running gas out now. Let's try it again.
Now it's starving for fuel. Well, hooray! But obviously some things are not right.
Woo! Little tweaking on it. I've got to get that. You heard it, didn't you?
Just made it all get out.
Well, hooray, it runs. But Some common issues found in the first two runs was the carburetor would just sitting there would overfill with fuel, and then after about 15 seconds of the engine running, it would become starved for fuel. I wanted to verify fuel freely flowing to the carburetor through the line, and so I removed the line at the carburetor, and there was gas flowing out the line, but it seemed a real weak flow rate to me. Obviously, the carburetor has got to be looked at, but I first want to look at the gas tank fuel level and that flow rate. I had only put about 2 gallons of fresh gas I had here in a gas container, so I want to just measure and see how much fuel is in the tank. Looking for a fuel gauge out of my stick scraps. There's a piece of oak, but that's not long enough. What is this? Oh, perfect. That is perfect. That's a piece of alder, looks like. Okay, I need to make that a little bit shorter. I drilled a hole in one end. Okay. Okay, I'm gonna put a little hole in the end of it. I'm gonna put a little screw head on this here and just hang that back there, and it'll be perfect fuel gauge. It's gonna be great. Mexican style street corn and a little bit of iced coffee. Pretty dang good. Lincoln designed this welder with a gravity feed fuel system. There's no fuel pump. So with more fluid level in the fuel tank, more hydrostatic head you have on the fuel line. This fuel tank is designed in a flattened oval design. I just love it. This cross-sectional drawing of the fuel tank illustrates how you have to have about 3/4 of an inch of fluid level in the middle of the tank to reach over the outlet port. This means about 1.5 gallons or more of fuel to even begin to have any outflow. So I would suggest 4 or 5 gallons minimum in the tank. So I added some graduation marks to the fuel tank measuring stick. And I added about 4 gallons of fresh fuel. I then pulled the carburetor to go through it again. The Marvel Schiebler carb on this machine is a Type A fixed jet. Well, I found the problem with the engine's lack of fuel flow from the main jet. And unfortunately, like many times before, I didn't catch this second teardown of the carburetor. The lines indicate the location of the main jet. This drawing is turned around the opposite direction. You can tell this main jet, number 24, is angled down to the very bottom of the bowl when it's screwed in. And it picks up all its fuel from the bottom of the bowl. The entire bottom of this fuel bowl is filled with a dried cake. I definitely needed one of these instead of one of these. That solid cake was just flush with this bottom of this plug. I simply missed it before. I just scraped all this dried cake out with a small screwdriver and a pick, and then flushed it with solvents and carb clean. I didn't find anything particularly wrong with the float and the needle valve stop. I'll just be careful putting it back together. The carb is now back together, but much cleaner and ready to go. As I began to mount the cleaned up carburetor onto the intake manifold, the vent tube was prohibiting the carburetor from completely mounting flush to the intake manifold. So I just cut the bottom portion of the vent tube off. Got the cleaned up carb reattached, ready to go. Hooray! No more carburetor overflowing with fuel or engine starving for fuel. Okay, with more runs of the engine and while watching the engine temperature and radiator function, I thought about my initial idea. The thermostat might be okay. Yeah, right. Good grief. Change the $5 thermostat out. I clipped out the end of this video segment. The engine ran, or I let it run for another 7 minutes. It ran absolutely perfectly. Hooray, this machine is running great. Now to get the welding components working. But first, a quick preview with the hood and the doors on it. Nice.
And again, at the 15th. One stroke off the lead, heading into the weekend.
This is, now 3 straight majors have been in the mix, and so it's good stuff.
Open champion Francesco Molinari took only 25 putts as he carded a bogey-free round of 67, joining the leaders at 700. Brooks Koepka climbed his way back to the top of a strong leaderboard with a birdie at the last.
Some people don't think I'm mentally tough or tough in general, but I think I am. I think I've proven that with 3 trophies, and you can't win it on Friday, so you still got a lot of golf to play.
5 players, all major champions, tied at the halfway point, the most in Masters history. The peacefulness of morning's early light uncovers the dedication and hard work that goes into preparing golf's grandest stage.
I first met him in 1963. He was establishing himself as one of these pro. In my view, Jenkins was the cleverest writer in sports. I can't think of anyone who equaled him. He could turn a phrase with such humor contained in it that you go back.
The final group arrives to the tee. Molinari first.
Yeah, we got all but one of these. This is the one that was on the bottom of the unit mix. It is
Tiger's turn.
loaded up for the belly. Got a big plane going on. I can't get that one screw out of there, but I'm gonna be able to fix it without cleaning all up and everything.
Tiger strode safely on the green, while the others found themselves on the wrong side of Ray's Creek. The 12th hole has spoken. Up ahead, it was anything but silent. Koepka for eagle at 13. Trying to get that double right back and got it.
performance tracker ever made. At less than a swing weight, Super Tags are the smallest, lightest, and most powerful way to add breakthrough intelligence to every club. Plus, strokes gained are automatically calculated just like the pros. And now, 360-degree replays of your swing and club metrics are captured for each shot with unmatched reliability. GameTrax 360 from Sky Golf. Nothing else comes close.
The PGA Tour's best head west for a shootout in the Lone Star State.
I took a photo of the faceplate on the stator housing and blew it up, and wow, I can read it. Amazing. Man, I'm so thankful to find this wiring schematic. With it, I learned what to do with the two wires that were laying on the stator housing twisted together when I acquired this machine. Oh my, I mean a big hooray. I mean, everything is working now. I'm trial fitting the short hood. I'm putting 4 of these units together for the hold downs for the short hood. Just topping off the battery charge.
Okay. Mounted a little rubber strap on the back of the battery compartment. The battery will have to just be put in there, and then it'll have to be pushed back a little bit, and then
after putting the battery in there, then I made this door for it. So fixing to mount that all together. Here's the mounting brackets. I just stuck them on the unit temporarily, hand tight. We'll take them off. I think it is ready to be put to work. This machine went through quite a transition. Now for why did I do this? Just look at and read this page. Well, here it is, big guy. About to be on its way to you. He has also said by phone, etc., that the welder is working great and he loves it. Just makes my day. If you like the video, click the subscribe button below the video window. It's painless.